distinguished speaker, may I invite Dr. Manoj P. Samuel, Director, Kerala State Council for Science, Technology and Environment, Center for Water Resources Development and Management.
Good afternoon. Respected Dr. T. Ramasami, Dr. Binuja Thomas, other dignitaries and delegates. Now we are going to have Dr. G.N. Ramachandran Memorial Lecture. Dr. G.N. Ramachandran was a pioneering Indian biophysicist who founded the Molecular Biophysics Unit at Indian Institute of Sciences, Bangalore. Trained under Sir C.V. Raman at Cambridge, he became an expert in X-ray crystallography and molecular modeling. He is best known for creating the Ramachandran plot, a fundamental tool in protein structural analysis, and for proposing a triple helical structure for collagen. A fellow of the Royal Society, he is remembered as one of India's foremost scientists in structural biology. With much respect, I invite Dr. T. Ramasami for this lecture. Before that, I will just read out his biodata in a few seconds. Dr. Tirumalachari Ramasami, former Secretary to the Government of India in the Department of Science and Technology, is a technologist turned scientist and a scientist turned civil servant. He holds master's degree in leather technology from the University of Madras and doctoral degree in chemistry from the University of Leeds in the UK. His research interests span wide range of topics and contributions are in the diverse areas of sciences. He has published more than 250 research papers, filed over 50 patents, and developed 12 process know-hows. Several technologies developed by his group are in extensive commercial use in the country and abroad as well. Two of his technologies that used the understanding of metal ligand interactions were first of its kind in the world and is established the indigenous effort of India in leather auxiliaries. His leadership in CSIR-Central Leather Research Institute gained for the institute a global leadership in leather research, and his contributions strengthening academic research and industry partnership in leather sector are well known. His leadership to CLRI in a moment of crisis helped to save around 250,000 jobs, rupees 6,000 crores annual turnover, and rupees 3,500 crores of annual export. He credited with the mass effort by over 900 tanneries in Tamil Nadu going green in just about 18 months. He is one of the longest serving secretaries in Government of India, and during his period as a secretary, Department of Science and Technology, he introduced several new programs and mechanisms for R&D funding and many novel schemes. For example, Inspire, which has emerged as the game changer in the attraction of talents to the science. PERS, focused on rejuvenation of science and research in Indian universities, and establishment of Science Engineering Research Board aimed at debureaucratization of R&D funding are indicators of the directorial changes in science landscape in India with which he was closely associated. He was a major contributor to the formulation of Science, Technology and Innovation Policy in India in 2013. Among his numerous honors, Dr. Ramasami was awarded the Shanti Swarup Bhatnagar Prize for Chemical Sciences in 1993, Padma Shri in 2001, Padma Bhushan in 2014, and also he is an elected fellow of Indian National Science Academy, Indian Academy of Sciences, National Academy of Sciences in India, Indian National Academy of Engineers, and the World Academy of Science. He is currently a member of ABEO, Organization of Prohibition of Chemical Weapons, and also honorary professor at ISER Mohali as well as ISER Kolkata. He is currently Naidumma Abdul Wahab Chair Professor at the Department of Leather Technology, Anna University, Chennai, and he teaches to the UG as well as PG students about the fundamentals of leather science. With a great respect, I request Dr. T. Ramasami for the G. N. Ramachandran Memorial Lecture. Thank you.
Very good afternoon. I thank the council and the organizers for having given me an opportunity to pay a tribute to a scientist who transformed my life. The theme of this Congress talks about celebrating science for transforming lives. Earlier speakers retraced the path and also projected forward where the science has made both perceptible and imperceptible impact on the development of India. But I am going to talk to you today, pay a tribute to a scientist, celebrate a scientist who transformed some lives, including mine. Therefore, it's going to be one of those early time experiments, sciences. It's interesting, this conference organizers picked up one of my old photographs. It was pointed out, fortunately it is my photograph, I assure you. They were trying to tell me that I should talk science and not policy that I played around with in the government. So this is going to be a science-based talk. At that time, I was actually a scientist. Today, I am here to pay a tribute to Professor J. N. Ramachandran. Tribute is essentially best done by celebrating the legacy that a person has left, and that legacy which sustains long after the person is gone. To me, Professor Ramachandran was a forerunner in Indian science. He did not just impact me, but I think impact Indian science itself. And he probably brought India to the world map in the science sector. Before I start my lecture, I'll share an anecdote. Dorothy Hodgkin, who was a Nobel Prize winner, was giving a lecture in University of Madras when I was a young man. I was younger than that photograph at that time. And she had a world map where no country was named. Every country is named only by the major scientific contribution that country had contributed to. Russia had neutron diffraction. India had X-ray diffraction. And that was the contribution of Professor Ramachandran. So she recognized India by GNR on a world map. And many of you who might understand as chemists something called neighboring group effect. So GNR had a neighboring group effect on CSIR-CLRA. Then I had the effect on myself in my personal life. I'm going to share with you in 3 parts. It was already pointed out to you that Professor Ramachandran's credentials, and I'm not going to pick that up. But this occasion is special because he's from Ernakulam and he studied here. He did his intermediate or something like that up to the stage in Ernakulam. So this is a story of a man from the soil, local soil, Ernakulam. He was born on October 8, 1922. And he, of course, discovered triple helical structure of collagen. It was published in the Nature in 1954. I would say the Ramachandran plot is a game-changing contribution that came from this country. And these are very outstanding contributions that return the name of India in, let me say, basic science. He got his undergraduate course from St. Joseph's College, to which I am emotionally attracted to. This college carries the motto of truth and service. St. Joseph's College is for truth and goodness, pro bono et vero. And he is one of those celebrated persons in this national space. There are people in science who make one or two, but this man had three major contributions, path-breaking. He passed away on 7th of April 2001. I was telling some people, physically they may be going away, but the spirit continues. To me, the spirit of G. N. Ramachandran still lives on, especially for those for whom basic science is an inspiration. Those of them who are able to see beauty in knowledge look at Ramachandran as their spirit. Therefore, I am going to present this as a tribute to a spirit that, in my opinion, lives on. He was a pioneer, and he laid the foundation of what I call the structural biology and molecular biophysics in this country. Today, structural biology research is prospered globally. He broke new grounds for that area. In the Federation of Science, he was a pioneer before many others could follow. He, as I said before, contributed three major discoveries, which we will discuss today. If we take this field of structural biology in the 1950s, people used to look at the structural biology of proteins, biomacromolecules. They were all understanding them. That was a global trend at that time. Several Nobel Prizes were in that order. You look at 1954, Linus Pauling, structural biology. 1958, Sanger. 1962, Perutz and Kendrew. And famous DNA, 1962, Crick and Watson. 64, Dorothy Hodgkin I talked about. Now, later on also it continues, Venki Ramakrishnan in 2009, and even as early as recent as 2024, you are looking at Nobel Prizes into this area. Therefore, we need to ask the relevance of what he did as structural biology contribution to the process, and the reason I'm trying to argue on this process is a living spirit is because that discipline still remains in the forefront of science itself. X-ray structural determination at that time was becoming feasible. It turns out the alpha helical structure of protein itself was worked on 53. Okay? Now, the DNA structure was solved also that year in 53. Now, 1954, triple helical structure of collagen was solved by G. N. Ramachandran. He entered the scene. 1953, DNA's double helical structure is reported. 1954, G. N. Ramachandran carried out research on collagen structure, and he entered the scene and set up an imprint for this country that lasts in the field of structural biology. I picked up a photograph from his old Madras school. He called the University of Madras. He talked about University of Madras gave him a place, maybe table and chair, very limited infrastructure. What was driving them, this particular school has very important people in this photograph. I won't go into the details of those. They are very curious, very determined, and he dreamt of solving mysteries that no one else could. And that was the spirit of the man. It turned out, sometime later, Leather Institute dedicated an auditorium named Triple Helix. So I had the privilege of recording a video of Professor Ramachandran. Personally, I went to him. Then he narrated the story I picked up from here. And I thought of playing that video itself, but it's too long. I believe he met J.D. Bernal. It was he who suggested to GNR that he attempted the structure of collagen. Collagen is skin protein, the skin protein. It's interesting, the last lecture finished with fish skin and it becoming a product, but I think that's the reality of the process. When Ramachandran wanted to solve the structure of collagen, he approached the director of the next neighboring institute called Leather Research Institute. because leather deals with skin. So I went to Professor Dr. Naidamma for a purified sample of collagen. It turned out that kangaroo tail had a source of pure collagen. So those days, all the regulations existed. Dr. Naidamma, of course, was a senior man. He managed to bring a kangaroo tail tendon from Australia. Don't ask me whether it was legal or otherwise. But he brought this and it was purified, and the triple helical structure of collagen was published in Nature in 1954 August. It's a landmark in structural biology. At that time, we thought there's only one type of collagen, but now we know there are 23 different types. But Madras, today the structure is called Madras triple helical structure. The city of Madras, which was otherwise known for sambar and idli, was known for triple helical structure. It gained an identity. It is a coil-coil structure. I won't go to the details of those. It was published in August in Nature 1954 by his colleague. Karta must be from this part of the country. And they were pathbreakers. It drew the attention of the international community. When you do something very good, people start admiring you. The hidden admiration leads to jealousy. So his contribution also brought that kind of jealousy, and I won't name the people in this process. And they came back and said, this structure may not be right for some reasons. But let me tell you what the features of this Madras model of collagen. They taught about 3 helices, 3 polypeptide chains, each in a left-handed helix, intertwining into right-handed superhelix, stabilized by repeating glycine XY sequence with proline and hydroxyproline defining the strong fibrous protein. The collagen, which is a molecular weight of 300,000, is made inside the cell within 6 minutes. But at that time, there is no hydroxyproline because it's nearby soluble. It has to be transported out. Then the translation takes place in the extracellular process, becomes a hydroxyproline. That becomes the fibrous protein. They've described this 3 standards rope, 3 polypeptide chains coiled around each other, left-handed individual chains, and right-handed superhelix, and to form what I call a larger, tight right-handed helix. It turns out, structurally, if there need to be a very tight packing, every third unit must be a glycine. You put one alanine, there will be steric hindrance because locking process will be a problem. So nature chose this glycine for that structurally to be stronger, and the crucial repeating sequence allows paints to pack lightly and glycine small site when the helix core. All these came to be established later, but the structure was solved before, 7 sequence and so on. And they talked about 2 hydrogen bonds per chain, some later modified with one water mediated and one on its own. This structure, although may have undergone slight modifications, this structure of Madras structure remains constant. And that's by basically the most important scientific contribution of India is triple helical structure of collagen. And that's GNR. Of course, someone in Yale University presented a counter argument on the grounds of potential steric hindrance for this locking, and he challenged it. Most people, when you get into this problem, when you have human ingenuity, they will always be challenged. Now, GNR took this argument emotionally, and he had developed what they call a sci-fi diagram, because it's called a Ramachandran plot, for addressing those arguments based on a theoretical model of protein conformation processes. Let me say there's a fundamental principle that he developed. This needs to be, in my opinion, to be considered a forerunner for lots of bioinformatics and other science-based, IT-based models. This was published in Journal of Molecular Biology in 1963. Of course, when you talk about this protein conformation, talk about primary protein chain structure, secondary, tertiary, quaternary, all the structural systems came into play. And I won't go into the details of those, but primarily what it meant was essentially the dihedral angles around this bond that rotates the process, and talked about a protein conformation and prepared a plot of this kind. Now, this is, they call it Ramachandran plot, and Ramachandran plot today is almost a Bible of protein conformation analysis. It so happened when such a thing comes from a country like ours, it laid the foundation for understanding the protein folding and analysis of protein conformation of polymers, biopolymers. Naturally, when it's happened, somebody countered this plot. Copper bleomycin structure doesn't fit into this. So they've done the X-ray structure, copper bleomycin doesn't fit into this plot. They went to drill holes in the plot. But somebody went and repeated that experiment. The X-ray structure, when it was properly done, it went right into the plot. So Ramachandran plot is truly a case of a theory validating experiment. Usually experiment validates theories. Your theory validates the experiment itself. So currently the plot has become the foundation of the conformation analysis of proteins, and it's a fundamental contribution that sustains years and so on. I don't think fundamentals don't change. Of course, in 1971, Ramachandran and A.V. Lakshmanarayana developed coevolution back projection algorithms, which formed a basis for image reconstruction. And this was published in Proceedings of the National Academy of Sciences in 1971. All these three contributions, in my opinion, wrote the signature of India, not Ramachandran, on the science literature. And then you ask the question, okay, is it sustained? Or after Ramachandran, everything disappeared? What is happening in this country? So what I have done here, to look at the growth story of this country in the field of structural biology research by way of publication outputs. And you can see, they call it hockey stick, whatever they want to call, at least in number game, because quality is different. We have to be careful about that. And you can see there is a reasonably strong following for the structural biology work. And I would say GNR can be credited with the reputation of having laid the foundation for research on structural biology in this country, which is currently sustained. That's got our legacies. In the research base in this area, it has expanded the growth story, reflected in terms of publications in this domain, and I call this a tribute to a leader, because with something that is sustained over a period of time beyond his time, so I thought about Gandhi may be gone, Gandhism survives. Similarly, GNR's structural biology sustains in this country. And we take this process in terms of, since 2000, you look at this area a little more critically in structural biology in terms of various countries and make a comparison, because eventually everywhere now we have to talk about how India is doing with respect to somebody else. I thought India can worry about India itself, but unfortunately the current tendency we have to how are you doing with respect to India, and I've given you a relative comparison. I think we are perhaps the third largest base after China, US and India. But those of them who talked about India-China comparison must realize China has 22 lakh scientists, full-time equivalents, and US has 14.7 lakh full-time equivalent scientists. India, when I went to Delhi, was 1.34 lakhs. Now to move to 3.3. So fundamentally, the number of scientists is also important in this area, but I think it's fairly, but the growth profile is, if you take India itself, it is continued to grow. So that's a tribute I like to once again offer to GNR, because it is sustained. But as somebody who had been in the domain for a while, I would say nation is still waiting for a discovery that matched those of J.N. Ramachandran. We have done good things, we are measured, but I think the quality of that kind of impact, GNR was unique. Now take the bioinformatics. Again, you would see India is in a reasonable dimension in this domain. Therefore, what I'm trying to tell you, these are data which are last week based system. This Ramachandran plot seeded a certain interest in this game, and today India ranks third among the Committee of Nations with number of publications in Web of Science Index publications, and I would say the legacy of the master prevails. So I have mentioned three foundational work for performing at the University of Madras from 1950s to early 1970. Inspired large number of young people. At that time, this work was done in Arakappa College of Technology, where the work was done. And post-retirement, I'm also located in that place because I'm trying to still get hold of some inspiration spirit that GNR provided. The inspiration of GNR continues to influence the neighboring institution, CLRI. And personally, I'm a beneficiary of the inspiring influence of Professor Ramachandran myself. When I saw him, I was 16 years old. Therefore, I can tell you the teenage effect. And I call this evidence of neighboring group effect. Organic chemical cut anchimeric resistance. I think neighboring group effect is a good terminology here, and what CLRI has done in this process. If you take collagen research in this country, and then look at CLR, collagen research, you would see CSIR is figuring high. And within CSIR, CLRI is the main source. And it has perhaps outperformed many other research institutions in India. I'm not talking about within CSIR, it's about national space. And I will now attribute this to the legacy of GNR and the inspiration he provided on CLRI, which continues even today. That's what it implies. And now you ask a question, okay, CLRI is doing this, who are those players? People in the institute. And wherever the CLRI is picked up, this is an Indian map, you can see the largest number of the leather-like samples happen to be in this map, Indian space, or from CLRI. Therefore, that impact that he made on the institution continues. Legacy of GNR carried out since 2001 publications, you will recognize CLRI towards the front. So today, CLRI has emerged as a reliable source of not science of the kind Ramachandran did, but technologies for collagen-based biomaterials, because the priorities change. In the last 20 years, the Institute has released some technologies for collagen-based biomaterials to more than a number of clients. It turns out 80% of the products in the marketplace based on collagen basis are from this institute. So whatever the marketplace systems are. And this diversity of products, reconstituted collagen sheet, controlled drug delivery system, nanocomposites, lens bandage, granules. And significant number of students have obtained their doctoral degrees on the research in collagen-based, not biomaterials, not just collagen-based materials, not biomaterials. So when he has made such a big impact on the institution, it's only fair that the institute honors the contribution. So they decided to dedicate their auditorium to the contribution of Ramachandran, but not by his name Ramachandran, but his contribution triple helix. So the auditorium in CLR is called triple helix, and is one of the famous conferences. This is the triple helix. I would call this, I talked about the spirit of Ramachandran, but the spirit also has to be embodied. Otherwise, it will have other meaning, and especially in our context. So there's an embodiment. That embodiment is this the triple helix auditorium in the Leather Institute, and it is one of the, let me say, most visited places, and large number of impact-making scientists have come and given lectures here. And therefore, Venki Ramakrishna has given 2 lectures in this place, because for him, Ramachandran was an inspiration myself. It turned out that I joined the Leather Institute, the KSC College of Technology for an undergraduate degree in 1964, but Ramachandran was doing his work at that time. So I feel blessed that I was in the company of a master. I was still a teenager. So people like me, he remained a role model. And a role model for pursuing science for its own beauty, not applications and so on, for its own beauty. I remember the year 1968, maybe 67 sometimes, 68, 67, I'm not very sure, but it might be one of those years. He brought 4 Nobel Prize winners, Linus Pauling, Lawrence Bragg, Blackett, and Dorothy Hodgkin, and held them at a symposium. And that was a fantastic impact on all of us who are youngsters and teenagers. That impact, even today, sustains. And he was a person like Linus Pauling, post the conference, he gave a lecture in my institute, CLRA, and said, but for the fact Ramachandran, India would got Nobel Prize a long time back. He was in that league. And as I said earlier, my own work, I recognized for something I did in chromium, other thing is collagen. So the collagen pertained not of the class, but the spirit of first principle based discovery. It is not an extension from some other place. So Ramachandran did not get inspired by somebody else. Ramachandran inspired others. So the first principle based application of basic science, I have been able to do that. So in the first principle understanding of a complex phenomena of industrial relevance like tanning, which was described rather than defined. And what I try to do is to give a unified theory for mechanism of tanning, which is nothing but stabilization of collagen against heat and collagenase, enzymatic degradation. And understanding of the collagen metabolism and catabolism for design and development of smart collagen-based biomaterials for wound healing and burn dressing. And gaining structural insight in the collagen-related disorders with potential relevance to disease biology of the connective tissue protein, including some genetic diseases. This is the kind of thing that we have been able to do. So understanding molecular processes at the time when I was a student in the 3rd year, 4th year, I asked my teacher, there's a mechanism of this tanning, that tanning, that tanning. Can you get one theory which will describe the entire process? It turned out I couldn't get an answer, but finally I decided to do it myself in later life. So what we did was essentially proposed a unified theory for understanding tanning processes as a stabilization of collagen from the molecular level. So it can do the molecular species bind to the reactive sites in collagen and stabilize the protein against collagenase? Or do they deactivate collagenase so that collagenase cannot act? Or do they bring about binding or the conformation of a collagen such that the regions, hypersensitive regions are protected against? Or a combination of any one of these above. This was the theory questions we asked, and we went through collagenase. Primarily the skin is degraded by 2 sources. Because we renew our skin every day, in the skin we already have collagenase native to the skin. And bacteria, they carry collagenase because they have an animal they have to eat. Now they have to get the skin out first. So bacteria has collagenase, and then unless collagenase breaks collagen into 2 bits or 2/3 and 1/3 bit, no other enzyme can work. So collagenase, the bacterial collagenase is responsible for putrefaction of skin. Can we address that issue? And we have more details of those. So we picked up some chromomolecular species, to get into the process. It turns out the collagen is organized in the skin along the corner of a regular pentagon. It turns out long before man talked about nanostructures, skin is a great nanostructure. It turns out the pore cavity of the 5 collagen molecules organized along the regular pentagon is 1 angstrom unit in its bed, 0.7 nanometer when it is dry. Essentially talking about 1 nanometer or 0.7 nanometer, depending on wet or dry. At 0.7, water cannot be a liquid. because water thin bonding systems required. So nature has designed the system such that the skin can evaporate water at body temperature. This is the beauty of the process. Now the question here, if there are molecules which are 5.8, 7.2, many of these cannot even enter in those process units. So these are, what happened is, I won't go to the details of those. Primarily, what the tanning molecules do, increase the intermolecular ordering. So long chain ordering takes place, and that gives the thermal stability, and we are able to show species-wise changes in the thermal stability depending on the ability to induce long-range order. Then we talked about understanding collagenase, what does it do to the enzyme? And it was possible for collagenase first binds to collagen into this process, and this is a dynamic simulation. Now, if you are able to constrain these similar structures, then collagen breakdown will not take place. And these are computational techniques that are done later. I will not go into those. So primarily, some species were able to competitively inhibit, some species were able to deactivate, some species were able to do nothing. So it was possible for us to do a species-based understanding of how tanning process takes place. And we are able to correlate changes in the D-periodicity, the long-range order, with the thermal stability and the kind of inhibition processes of collagenase, we can correlate with respect to this species-active processes. We are not limited only to chromium. We went and looked at many other tanning materials as well, and this theory more or less holds. We can present a unified theory in terms of these mechanisms. Now, collagen is surrounded by water, and tanning process also has an influence of water. So what we try to do is what happens to the water structure. And water, there are some water molecules are bound, some are the translational frequencies and so on. And it so happened they are able to get a third contribution in terms of the tanning molecules changing the data dynamics, translation times, and we are able to correlate the mechanism. Now, the models see, when it comes to a certain point of time, when you cannot do experimental something, you go to the theory. So we went and did some structural stability of collagen and theoretical modulations, and I'll go into the details of those. What we try to do is to understand how collagen interacts with the flavonoid. The reason I put it together, I'm tweaking in Kerala. And Kerala, people understand arthritis very well. Rheumatoid arthritis and the kind of Ayurvedic processes. And they use flavonoids. Flavonoids are good tanning molecules. And they interact with these processes. And the management of arthritis, they play an important part. It turns out, we were able to simulate the interaction between collagen chain and flavonoids. It turns out it is possible for us to calculate the interfacial volume between the molecular space, flavonoid structure and the distance, and the binding constant. So no number of binding, it's essentially a volume. Solvent excluded volume provides the processes, and in some sense inflammation issues are addressed. So the geometrical factors and solvent volumes seem to influence the host-guest interactions, and in some sense, tissue inflammation arthritic conditions is an aspect of protein-water interactions. And we are able to at least understand how these structures can participate in the management of the disease. Now, in building blocks of collagen-based part materials, collagen as a protein provides uniqueness of structures. It is a tissue organ playing roles of functions. It is immunogenicity, acceptable in nature. It's a good carrier to play a host for drugs and control drug mechanism, and they talk about biodegradability and so on. It turns out the Leather Institute was able to develop some burn resisting materials based on our understanding. These are the processes which happened. These are the products which came out of these processes. These are okay. But when you do all this, You get excited when you get a paper published in a good journal. But when you do this kind of work, you look at the smile of people who get the benefit. These children who are standing there, 12 of them, they were affected in a fire accident in Kumbakonam when I was in the institute. And they received those collagen-based biomaterials, and many of them, other people had very serious damages. The smile on their faces at that time gave me more satisfaction than the paper I did not publish in another journal. And this individual, you can see what same person, what we did, this unfortunately could not be commercialized, this part. What we did on the collagen system, we set up not only antibiotics, controlled therapy systems, but all rheumatoid growth factors, and we are attempted to get a scarless healing. Scarless healing is really this one particular case we are able to establish. Unfortunately, this could not be commercialized. So current research priorities in collagen research, look at the window of current research. I'm not talking about India. Wound healing, regenerative therapy for bone and joint-related disorders, smart biomaterial design, disease biology of connective disorder. There's one disease, osteoporosis imperfecta, which is one glycine is replaced by alanine. One glycine replaced by an alanine, and the child dies before the age of 12. There's no cure. Because one alanine is replaced, it cannot fold. And it's a autoimmune disease, it's a genetic disease. The understanding process of autoimmune diseases are fundamental in this process. So genetic code expanded collagen like protein through recombinant technologies, tissue engineering for smart applications and so on are the directions in which things are going. Now I'm coming back to the core end. You see, Professor Jianna's own work was known for its absolute excellence at the very best, and gained global competitiveness in discovery science. He was ahead of everybody, many other people outside the country with far better equipment, infrastructure were jealous of the man who had nothing because his mind was powerful. He had gift of God, so he outperformed competitiveness global science. Many science activities, unfortunately, are derivative science with very low application potentials. They are good for publications and patents and getting promotions in the jobs. You can design a creative technological solution to national problems. It is a relevance axis. And today, Master of Science, in the morning you can serve relevance of science. Changing, transforming lives, relevance is an issue. I think what is important, discovering gainful solutions at affordable cost for global use. And I think that's the spirit of J.N. Ramachandran, in my opinion. That's the lessons that I've learned from him. And I would say, in closing, there's an evidence of a strong footprint of GNR in the structural biology landscape of the world in the form of triple helical structure of collagen, Ramachandran plot, and tomography. The evidence in the form of publications in the area of structural biology emanating from India and collagen research in CLR is the legacy was presented in tribute to GNR. I shared with an anecdotal experience of inspiration that I received when I was a teenager from him and a value of the master, and I would say he talked about transforming lives. It transformed my life. I can say that very frankly. And to me, GNR may have led the planet Earth on April 7, 2001, but his legacy prevails. In the mind of several of us who witnessed the scientific temper of this man, he is a living spirit. And Triple Helix Auditorium is just an embodiment of the great work done in India in the 1950s. With very limited infrastructure, only through human genius and creativity that rose above all limitations of all kinds. I think the man born at Ernakulam scaled heights above Mount Everest, in my opinion. And I believe for all his scientific contributions are the world class, the major awards and prizes missed this master. And I'm not going to sit and languish. He missed the prizes which missed the master. So the last is for the Nobel Prize, and Nobel Prize missed both Gandhi and GNR. I think GNR is in good company. Thank you very much. Thank you for all this co-traveling. I've been a beneficiary in life from the inspiration provided by Ramachandran and his work ethics. I hope some of you would benefit too from his inspirational work of Ramachandran and the like, carrying forward his legacy. And I believe the legacy of JNR should live on. I want the younger people in this audience to sustain it. Thank you very much.
Thank you, Dr. Ramasami, for that insightful lecture. I now invite Professor Sudhir, Executive Vice President of Kerala State Council of Science, Technology and Environment and President of 38th Kerala Science Congress, to deliver a memento. I also invite Dr. Ramasami to accept the memento.
Thank you, sir. May I now invite Dr. Binduja Thomas, Senior Principal Scientist, Kerala State Council for Science, Technology and Environment, to deliver the vote of thanks.
Respected dignitaries on the dais, distinguished guests, invitees and delegates of the 30th Kerala Science Congress. So we have come to the end of G.N. Ramachandran Memorial Lecture, organized as part of 30th Kerala Science Congress. So it was indeed an inspiring and thought-evoking session, an excellent presentation by Dr. T. Ramasami, former Secretary, Department of Science and Technology, Government of India, highlighting the journey of and the legacy of a great structural biologist who is basically a Malayali. And of course, he has highlighted the journey, emphasizing the journey from, especially highlighting his contributions, research contributions in collagen research, especially basically in the contributions in Indian science, as well as the contributions in CLRI, Central Leather Research Institute, and also how the research has contributed ultimately to the society in the development of biomaterials and similar research aspects and the way forward. So on behalf of Kerala State Council for Science, Technology and Environment, and also on behalf of the organizing committee of 30th Kerala Science Congress, let me extend a sincere gratitude and appreciation to Dr. T. Ramasami, sir. Thank you, sir. I also extend sincere gratitude to Dr. Manoj P. Samuel for giving an introduction to the speaker and also highlighting the contributions of Dr. G. N. Ramachandran, sir. And I would like to thank, special thanks to the organizing team of Focal Team and Memorial Lecture Committee, especially Sri Arjun Prasad and Dept, and also all the participants for actively participating in this session. Thank you once again.
Thank you, ma'am. Without any further delay, we will now move to the Kerala State Young Scientist Award presentations. Allow me to invite Dr. Jaya Jacob, Junior Scientist at Kerala State Council, Science, Technology and Environment, as well as Dr. Shankar P., Assistant Professor, Department of Mathematics at KUSAT, Dr. Anjita Vishwanath, Scientist and Engineer at Indian Space Research Organization, as well as Dr. Dept B., Junior Scientist, Kerala State Council for Science, Technology and Environment, to the dais. To welcome the gathering, allow me to invite Dr. Jaya Jacob, Junior Scientist, Kerala State Council for Science, Technology and Environment.
Respected dignitaries on the dais, distinguished scientists, fellow researchers, students and esteemed guests, It gives me immense pleasure to warmly welcome all of you to this very special session honoring the winners of the Kerala State Young Scientist Award, an award that truly celebrates scientific excellence, original thinking, and meaningful contributions to society through research and innovation. Today, we are very proud that we could felicitate two outstanding scientists whose work reflects the true spirit of recognition, rigor in research, and relevance to national priorities and the promise of shaping the future in science. We warmly welcome Dr. Anjita Vishwanath, scientist at ISRO Inertial Systems Unit, Thiruvananthapuram, whose work on indigenous inertial navigation and precision sensing technologies has played a vital role in major ISRO mission, including the reusable launch vehicle, landing experiments, and the Gaganyaan test flight. Her ongoing research on quantum inertial sensors and energy harvesters further strengthens India's future space missions. A warm welcome, Dr. Anjita. We are also privileged to have Dr. Shankar P., Assistant Professor, Department of Mathematics, Cochin University of Science and Technology, a mathematician here with us whose research in functional analysis and operator theory deepens our understanding of complex systems with strong relevance to quantum physics and modern mathematical analysis. We look forward to insightful presentations from both of you, from both our awardees, and to engaging discussions, especially to the young researchers here. We would request you to have a very meaningful discussion with the examples of young scientists right in front of you that will inspire you in your scientific journey ahead. Once again, a very warm welcome to our distinguished speakers. Also, a warm welcome to Dr. Dept, who has been organizing and coordinating this program. And we invite you all to a very insightful session ahead. Thank you.
For the presentations, I now invite Dr. Shankar P., Assistant Professor, Department of Mathematics at KSYSA.
Hello, yeah. So, good evening, good afternoon all. I would like to thank KSC for awarding me this Young Scientist Award. So thank you very much. So now we want to see, actually I am a pure mathematician, pure mathematics doing guy. But somehow I want to convince this to the public that whatever I am doing, that is relevant to the public. So I will try to make more mathematical, and for anyway there will be a mathematics will come, we cannot avoid that. So we will see what is this invariance of space problem. Actually this is a open problem, still this is not solved. If you solve this, so you may get some bigger award in the mathematical community, you will get the recognition. So before going to explain what is this problem, so I want to explain so that by the known word. Suppose you assume that like you have some live concert is going on. So when your live concert is going on, there will be a lot of musical instrument they will play. So when they play musical instrument, then you have vocals, guitar, drums. So then including that you will have crowd noise also. So there will be a crowd noise also. But with all these things, suppose your mic captures all these things and deliver all these things, this will be total messy. So total messy, you will not get anything clear. Okay. So for that what we need, we don't want the noise. So that means the mic or whatever that is you are having observer, it will take a messy signal, but then we don't need the same messy signal output. We need a clear whatever we need, like suppose you vocals, guitar, the limit we need the output. So there where the operator comes. So you can take C. So that is the thing, this is what invariance of space says. So you don't want any noise, but you need poor vocals, you need clean guitar. So then maybe there will be a lot of instruments. Some instruments you need some level. Okay, so some music, some level. So for that you maybe drums, if you don't want, you make it as a 0. I think these things you can consider as a subspaces. Okay, as a set or something, only pure vocals. So that means whatever pure vocals with the limit I am having, that is to come as a output, and the clean guitar also come as a output. Okay, so for that I will take those things as a subspace. So whatever I don't want that. That means when the mic should capture the power vocals, then that should convert them into vocals only without any noise and any other disturbance. So that's where your subspace comes. Okay, so that's where your subspace comes. So you need an operator or subspaces like this. Yeah, so that is the thing. You consider these vocals, guitar, drums as a subspaces, and before you are doing this equalizer, like you will have noisy only, but after doing your equalizer you will get poor vocals and clean guitar, all these things. So does this audio operator T preserves musical subspaces? That is the thing. Suppose you consider all the music instrument. So the question is now invariant subspace problem became whether he can preserve, it can take vocals to vocals, guitar to guitar, all these things. Okay. So this is how this will do. Yeah. So yeah, this will do because we can make, so you forgot about, if you know Hilbert space, it's not a problem. We can consider Hilbert space. So that means you consider full instrument as a one space, then all these vocals and the guitar as a subspaces. I need a operator, so equalizer, so that it makes your messy signals to the clean signals. Okay. So this is a, like, if you want, you can understand it very clearly with these applications. So that is the thing you need. So this as in the signal processing also. Even not only here, maybe you can take a transmitter. So if you want, you are watching TV, you are receiving mobile, all these things are there. But when you are in mobile internet also you are using, you need same kind of things. Like whatever exhibited from there, you should receive the same thing, then only you will get a poor correct signals. Okay, some messy things we should not want. Okay, that's where the key invariant subspace problem comes. So then this kind of spaces we have. So here also we will have some technical terms are there, so I cannot avoid it. Here this Berling subspaces, and you will have some composition operator. So this thing I will come to this one. Yeah. So what is this? So first we will try to understand, this is a mathematical slide. So you take an RD space. So RD space, you will have an integration representation also, you leave out. But you can have a sequence, like you take a sequences. So you apply F, then you go like this, then you can have this H2D. That means you take a sequences, you just sum it over, and so that the coefficients AN has to be square summable. So then your Z has to be from where? It is from the unit disk. Suppose you have a plane, you can take a disk from this. So this is called RD space. Yeah. So yeah. So then you have a RD space. So now we are going to have a subspaces of those RD spaces. So then we are going to have a lot of operators between them, lot of operators. So there, whether that operator can have a invariant subspaces. That is the question. Yeah. So now you take this multiplication operator, you can define F going to F psi. Just you multiply with some function. So that is the thing. Yeah. So you have this multiplication operator, and yeah. So what Berling proved. So this is a very old problem. So it's solved in 1948. What he proved that if you take an RD space, you take a multiplication operator by only mz. You are multiply whatever function is there only by z. So then you can find an invariant subspace for that. Okay, not only one invariant subspace, you can find all the invariant subspaces. Okay. So because of this one operator, the invariant subspace problem for this operator is solved. Okay. So if you take this, yeah, again I am repeating, you take a RD space and you consider multiplication operator by Z. So then all the invariant subspace, not only like this all the invariant subspace will look like your theta H2, where theta is an inner function, some kind of function. Okay. So this, after this result only people started looking at invariant subspace problem. So these things you can again relate it to your audio system and transmitting signals, all these things. So here what you need, you have a function, then you will have a music and you will have a noise also, but I need only music, I don't need noise. Okay, so then your theta h2 you can consider, and the theta h2 perp also you can consider, that also you can write as some theta n is h2. So you want to remove the noise, only you want music. So that means that this MP3 keeps only your music and it discards the noise. Okay, so this is the thing. So this was the application in MP3 compressions. Okay, so now, so what is invariance of space directly? So this is a mathematical thing. So you have an operator, bounded linear operator, you take a Banach space. So yeah, so in the Banach space, if you take any subspace, so then that it is called invariant, then the operator T should map to itself, T of Y subset of Y. Okay, so the invariant subspace problem is this one. Does any bounded linear operator on the Banach space as a closed invariant subspace? So this is a general question. If you take any operator as a non-trivial closed invariant subspace or not. So there are fewer for Banach space setting, for there are different spaces are there in mathematics. So you can take Banach space setting, the answer they found actually for some cases for finite dimensional and for non-separable case and normal operator and all. But there are counter example also. So there are some operator where you cannot have this invariant subspaces. Okay, so then you can take some L2 space like the n-flow proved something. So but what is there actually, the crux is there in the Hilbert space, this problem is still open. If you take an Hilbert space, so Hilbert space is nothing but an inner product space. You can, so only the advantage of studying inner space is if you take a one space, you can consider orthogonal complement of that one. The other space will be, you can orthogonal complement, you can write that one, that is a inner product, that has a geometry, more geometry it has. So that is the thing. The question is, if you take a bounded linear operator on the infinite dimensional separable Hilbert space, that has a closed invariance of space or not. Okay, for some cases it no, but it's not proved generally, but this problem translated into a finding a minimal invariance of space for your hyperbolic automorphism for the composition operator. If that all the minimal invariant subspaces are one dimensional, so then you can say that this invariant subspace problem has a solution. But this is a equivalent criterion, but it is not still solved. So it is there. Yeah. So now, yeah, what is composition operator? This is thing. You take unit disk D. So that means you take a complex plane. In the complex plane, you take only unit disk. So composition operator is defined as C phi of F equal to F composition phi. So but what are the other application of this invariant subspace problem is it has a stable quantum states and control theory, dynamics and PD signal processing, everything it will be applied. Yeah. So now what happened? So what happened in the case of anyway for our multiplication operator we have certain things using still now whatever we are having this mic and everything by known operator they found this thing. But if you want more clarity, more thing, you want to solve for more operator. If you take composition operator, if you solve this invariant subspace for the composition operator, then you will get some better versions of these preservers. Okay, in the real life application also. That's what we are going to do. So this composition operator will take you to the clean music. But the problem is for the composition operator also, for some cases only it is solved. The problem is often for most of the cases, like for phi. Okay, even this is not, we are not trying for general subspace. We are taking a subspace of the type theta h2. The theta h2 is a invariant subspaces of multiplication operator. So that is the thing. Yeah. Okay. Yeah. So now this is the question now. So whether for what kind of phi the theta h2 will be subset of theta h2 itself. Okay. So what are the phi such that C phi of theta h2 for theta h2 itself for the self maps phi. Yeah. So yeah. So you can take, I used theta. The theta is an inner function. So inner function means is geometry. You take a unit disk. In the unit disk it takes interior to the interior and boundary to boundary. That's the thing. So this, even this inner function, you can, the example is the Blaschke product and this singular inner function. So Blaschke product means it will have a 0, that means it will vanish if you substitute z of a in theta of z, so it will be 0. Okay, so it will, but if you take a singular inner function, it is a non-vanishing singular, non-vanishing inner functions. But these are the two examples, then what are all the inner functions? So you can write all the inner functions will be of this one only. This is a product, all the inner functions will be this product of Blaschke's and only singular inner function. These are the things will come. So the singular inner function will not have any zeros, but Blaschke product will have a zeros everywhere. So that is the thing. So that ANs are, you can consider as a zeros. Yeah. Okay. So then these are some of the known results for the Blaschke product. You can able to find the invariant subspaces. So yeah. So for the Blaschke product, you can able to find some previous known results these are, but we don't want to go into that format, but that what we did here. So we were only looking at the problem, it's raised by Matache. So he told that if you take two measures mu1, mu2, maybe now we can focus not only the same space invariant, you take a one space and apply the operator, whether it can go to different spaces also. Okay, so in between two different spaces, you find an operator, it takes this space to the another space. So that is the question. So here, he gave for the non-vanishing function s mu1, this is an inner function, whether C phi of s, this s mu1 h2 subset of s mu2 h2. So this is the thing. So this question he told, but this we cannot able to prove this directly for all this, but whether the equivalent condition you can able to give, whether some kind of measure theoretic equivalent condition you can able to give for the solution of this one. Yeah. So this one you can, so we found that not only for the singular function, you take any inner function, if theta 1 HP subset of theta 2 HP, then this quotient theta 1 composition phi by theta 2 belongs to bounded analytic function. It is a bounded analytic functions. So that's what we proved. Then we got some corollary using those things also. So as a, this thing. So then what we did for the Blaschke product also, we got some multiplicity criteria. So suppose you take C phi of B1, because this B1 is a Blaschke product, it has zeros. So the multiplities of zeros of B2 will be less than or equal to multiplities of zeros of B1 composition phi. So then this is equivalent to say that C phi B1 HP subset of B2 HP. So that is the thing. Yeah. So similarly for if you take phi, so phi also you can vary for automorphism. So what we did, so if you take an automorphism, you can write, so this you can write what? If you take any inner function, you can make separate this thing, Blaschke and shift operator. Okay, so because any inner function is a product of Blaschke and the shift operator to singular function. So Blaschke and the singular function. So Blaschke product and singular function. So then you can separate them for only phi is automorphism. If you take non-automorphism, you cannot able to do that. So for that we have an example here. So this is little bit, we have to do mathematics. So little bit technical. So I am leaving this. We can have an example. If you take non-automorphism for this phi, so then you will have examples such that this theorem, this result may not be true. Yeah. Okay. So now, yeah. So this is the major thing. So what we gave, suppose you take two different inner singular inner functions. So then s mu1 HP subset of s mu2 HP. So then we proved that we can give a measure theoretic characterization of this one using mu1 and mu2. Okay. That measure of the mu2 of E, the measure of the function S mu, like the mu2 E will be always less than or equal to mu1 pi of E. So for the elliptic automorphism with fixing 0, this some kind of special automorphism, otherwise you can say this automorphism. So this result using this we can give more elaborated version. If you take a automorphism, you take disk to disk, it has a fixed point anywhere in the disk. So then we can prove that this invariant subspaces to different subspaces using this measure theoretic characterization. This number 3 measure theoretic characterization, using that we can do. Yeah. So this is the thing we did with this paper. So the first paper you can see, this appeared in Journal of Mathematical Analysis and Application in the Elsewhere journal. So this is with my PhD student and my one of the collaborator, Muthu Kumar. Yeah. So my main thing is that this has a applications in your voice cancellation and sending the signals to, so TV signals, even mobile signals. Only as an example I gave for this musical instrument, but you can everywhere this kind of thing is applied. Yeah. Okay. Thank you.
Thank you, Dr. Shankar. I now invite Dr. Anjita Vishwanath, scientist and engineer at Indian Space Research Organization, for her presentation.
So, a very fine good afternoon to all the respected dignitaries on and off the dais and all dear delegates of the 38th Kerala Science Congress. So first of all, with immense gratitude, I take this as a privilege to present my contributions in engineering, indigenous inertial and quantum sensor technologies for India's space missions. So I'm a scientist engineer SE and I belong to Sensor Electronics Division, Advanced Sensors Group, ISRO Inertial Systems Unit. So about my background, I'm basically an electronics and communication engineering graduate from KSAT, optoelectronics and laser technology postgraduate again from KSAT, and after that I have done PhD in Earth to Satellite Free Space Optical Communication Links from IIT Delhi. And after completing my PhD, I have joined ISRO as scientist engineer, and now I continue my journey with ISRO. So to start with, the motivation behind my work is simple, but a powerful reality. Whatever may be the space mission, the success of the space mission depends upon the accuracy of the inertial navigation sensors or the inertial navigation systems. Whether it is Chandrayaan making a precision soft landing, or Gaganyaan ensuring the safety of the crew module during its ascent and re-entry, or an RLV, reusable launch vehicle, gliding back autonomously into Earth, it is the inertial sensors which are the silent decision makers. So, the success of a space mission depends upon the inertial sensors or the accuracy of the inertial navigation systems. So spanning from the development of robust inertial navigation sensors and fast and accurate navigation algorithms, I also dwell upon the design and development of electronic systems for the next generation quantum inertial sensors as well as sustainable energy harvesters for long duration planetary missions. So this is not just a scientific pursuit, but in fact it is a vision to build indigenous, high precision and future-ready sensors to enable India's strategic space missions. So to start with, if you take any inertial navigation system, the core of the inertial navigation system is the ISRO ring laser gyroscope. It is the most important angular motion sensor that is used to measure angular rate in all our launch vehicles and spacecraft. Unlike spinning mass gyroscopes, inertial navigation, this ILG, it basically has got an optical cavity in which you have two counter-propagating laser beams. And there is a frequency difference between the two counter-propagating laser beams, which directly gives you the measure of angular rate. So that is how the ILG functions as an angular motion sensor. So figure F4 shows the basic schematic or basic diagram of the ILG ring laser gyroscope, and the principle behind ILG is called the Satnag effect. As I said, the two parts Counter-propagating paths will have a frequency difference that is directly proportional to the angular rate. And that phenomenon is called Sachs-Nack effect, which is illustrated in figure F5. Now, what is the challenge in realizing this ILG? As seen in figure F6A, you can see for lower rotation rates, what happens is that these two counter-propagating laser beams couple to each other and you really do not get any output. You can see for a rate less than 833.467 degree per hour, you have a dead zone. Although you have an input, you really do not have an output. And that is not how your sensor should be working. So we have to address this lock-in problem. And what is the solution for it? Dither. Dither is a sinusoidal rotation which is coupled to the body of the ring laser gyroscope through a piezoelectric transducer, and what dither does is that it moves your gyro body to and fro with a very high frequency. But still you will have dynamic lock-in zones at crossover frequencies, and that is what is shown in figure B for rates less than 20.5 degree per hour. So our objective or our problem to address is this lock-in phenomenon to improve the stability, reliability as well as yield of the sensor. So as said, we have to overcome the problem of dynamic lock-in, the zero zones or the deadband zones at the crossover frequencies. So what you have to do is that you have to randomize the amplitude of the dither signal. So figure F7 shows the work in which I have patented the optimum dither random noise ratio, for which you can reduce the bias instability value to 0.015 degree per hour, which means you will have a really very good accuracy in your navigation. Now moving on to figure F8, you can see an automated threshold monitoring and control system which I have developed and ISRO has inducted into the production line of ILG. More than 100 sensors have already gone through the setup and it has improved the reliability to 92.3%. So here what we do is that we keep on monitoring and controlling the threshold voltage of ILG, which is one of the most important health monitoring parameter of ILG. So these are one of the two major contributions as far as sensor development was concerned. Now, moving on to the algorithm part of it. Once you have all the sensors, you have the system, you need to have the algorithm to do the navigation. So as I said in the very beginning, the accuracy of the navigation system depends solely on what is your initial orientation. So for you, to start this navigation, you have to know what is the initial orientation with respect to a reference coordinate frame. And once you obtain this initial orientation using the sensor data itself without any sort of external aid, you call that alignment self-alignment. So here, what is the criticality or what is the importance of this self-alignment algorithm when it comes especially to reusable launch vehicle as well as Gaganyaan missions is that there is no other way out, there is no other external sources available for you to achieve the initial orientation other than to develop this sort of an algorithm. So this algorithm was developed for the first time, and it was developed because of the criticality, the need for the accuracy in obtaining the initial orientation. So what happens if there happen to be initial alignment errors? See, if there happen to be initial alignment errors, it can lead to attitude errors during launch, your trajectory will deviate, and finally, your orbit insertion can itself go wrong, which can lead to mission failure. So that is the criticality of this problem. So your objective is to develop a new fast and accurate self-alignment algorithm where you really do not have any sort of external sources other than your sensors to find out the initial orientation. So here figure F9 shows the block schematic of the newly developed fast and accurate self-alignment algorithm. So before implementing this algorithm into our upcoming missions, we have to prove this algorithm in previous mission data. So figure F10 shows the assessment of this alignment algorithm in the historic Chandrayaan-2 mission data. So from this plot, you can find it is having a very fast convergence, which is even less than 100 seconds, with a very high accuracy, both in terms of azimuth as well as level angles. So having proven the accuracy and the fastness of convergence of the newly developed algorithm. This algorithm was implemented in reusable launch vehicle landing experiments, mission 1, 2, 3, as well as Gaganyaan TVD1 missions. So the mission, all these missions have successfully proved the algorithm we have developed. So now, moving on to the work what I'm currently focusing on, IISU is intending to build quantum inertial sensors that rely on the wave nature of ultra-cold atoms. So when you come to ultra-cold atoms, we have the wave nature wherein we'll be able to do interferometry, and that interferometry principle is used for sensing as illustrated in figure F13. When it comes to the sensitivity orders, when you move to the quantum nature, where you have the quantum nature of atom as the principle, you have a very improved accuracy in comparison to classical sensors as illustrated in this table. When you take an accelerometer, if your conventional sensor can measure 10 to the power minus 6g, your quantum sensors can measure 10 to the power minus 10g. When it comes to a gyroscope, if your conventional sensor can measure 10 to the power minus 2 degree per hour, your quantum sensors can measure up to 10 to the power minus 7 degree per hour. I basically focus on the electronics development, the indigenous development of electronic systems for these quantum inertial sensors or quantum inertial systems. So basically, like in a very, very simplified way, this is how the block diagram looks like. To the science chamber, we have the laser system, its electronics, control loops, then we have the detection electronics as well as a pulsing circuit which is required to ensure the complete synchronization. So this is in a very, very simple level, that is a block diagram. And in this, we have the extended version of this is the intensity stabilization loop, which is shown in figure F15, and the performance of the loop is shown in figure B. And 6 is an optical phase lock loop. Because in interferometry, we need Raman lasers, and we have to ensure the phase coherence of the Raman lasers. So for that, we have the optical phase lock loop, and this is the experimental setup for OPLL, and this is the block schematic. So these are the work which is being currently going on from my side. And to an advanced R&D area, I also focus on the development of sustainable energy harvesters for long duration interplanetary missions. So to start with, we have the Mars lander mission. So in Mars, as characterized by NASA's Environmental Assessment Compatible Meter, what happens is like in Mars, you have frequent strong dust storms, which characterizes the electrostatic building in atmosphere of Mars. So our idea or our concept is like, what if we use as abundant available mechanical and triboelectric or electrostatic energy in Martian environment to harvest energy, which can be used to power sensors which are used for planetary exploration. And these are called triboelectric nanogenerators. And it basically works on the principle of contact electrification and electrostatic induction as shown in the video. So we have a response project on this, and figure F18 shows the first prototype of the energy harvester, and figure B demonstrates a contact type triboelectric nanogenerator which can be incorporated into the wheel of the rover to harvest the energy. So, concluding upon the social relevance and tangible research output for the past 8 years of my work in ISRO, I basically focus on building indigenous capabilities in precision sensors, navigation systems, as well as triboelectric nanogenerators and cold atom interferometry-based quantum inertial sensors. I hold an Indian patent in ILG, and I have around 16 publications with over 230 citations, and I lead 2 major ISRO projects, one for developing the complete laser system for next generation quantum inertial sensors, and 2 for developing triboelectric nanogenerators for Mars lander mission. And most important part of my work is like the algorithm which I have developed is already being flight proven and qualified for all our reusable launch vehicle missions, as well as the upcoming Gaganyaan missions, the human rated space flight missions. So to conclude upon, All these which enable the precision navigation sensors, pioneering triboelectric nano generators, as well as advancing cold atom interferometry based quantum inertial sensors, it all contributes and empowers to our nation's space mission with precision, reliability, sustainability, and self-reliance. So thank you one and all. Once again, thanks a lot for having given this opportunity. Thank you so much.
Thank you, ma'am. To conclude this session, may I invite Dr. Deepti B., Junior Scientist, Kerala State Council for Science, Technology and Environment to deliver the vote of thanks.
So respected dignitaries, invitees and awardees, a good evening to all of you. So as we come close to the KSYSA presentation, I would like to extend my sincere gratitude to the awardees, Dr. Shankar P., Assistant Professor, Department of Mathematics, KUSAT, and Dr. Anchita Vishwanath, Scientist at ISRO, for their insightful presentation and for sharing their research experience with us. So like this award provides you the pathway for securing more awards in future for your research contribution. Thank you. I also extend my gratitude to Dr. Jaya Jacob, Junior Scientist at KCST, for the warm welcome and for introducing the awardees. Thank you, Dr. Jaya. Okay. So I will also like to acknowledge the continuous contribution of KCST, the organizing committee of 38th Kerala Science Congress, and the technical team for the smooth conduct of this program. So thank you all for participating in this lecture. Thank you.
Thank you, ma'am. Students who have not yet registered for the lectures will have the opportunity for a spot registration. Code will be displayed at the end of the discussion and it will also be available at the registration desk. We will now have a small tea break. Please join back in 15 minutes